Decimal. Topics covered: decimal, tens, hundreds, thousands, decimal fractions in the place value chart, expanded form. Decimal. The word deci means 1/10, 1 by 10. Fractions like 1 by 10, 1 by 100, 1 by 1000 can also be written in a different style called decimal system. 1 by 10 can be written as 0.1. 1 0 in the numerator, 1 decimal place. 1 by 100 can be written as 0.01. 2 zeros in the numerator, 2 decimal places. 1 by 1000 can be written as 0.001. 3 zeros in the numerator, 3 decimal places. Numbers like 0.1, 0.01, and 0.001 are called decimal numbers. Tens, 1 by 10 or 0.1. Tens are fractions with denominator 10. Let us divide a figure into 10 equal parts and shade one part. That part is 1 by 10. One shaded part represents 1 by 10 of the whole figure. We denote it by 0.1 and read it as decimal 1 or 0.1. Now we shade two parts. Two shaded parts represent 2 tens or 2 by 10 of the whole figure. We denote it by 0.2 and read it as decimal 2 or 0.2. We can continue the tens in the following chart. Fractional number 1/10, decimal fraction 1 by 10, decimal fraction with the decimal point 0.1, read as decimal 1. 2 tens, 2 by 10, 0.2, decimal 2. 3 tens, 3 by 10, 0.3, decimal 3. 4 tens, 4 by 10, 0.4, decimal 4. 5 tens, 5 by 10, 0.5, decimal 5. 6 tens, 6 by 10, 0.6, decimal 6. 7 tens, 7 by 10, 0.7, decimal 7. 8 tens, 8 by 10, 0.8, decimal 8. 9 tens, 9 by 10, 0.9, decimal 9. 10 tens, 10 by 10, 1.0, 1 decimal 0. 11 tens, 11 by 10, 1.1, 1 decimal 1. 12 tens, 12 by 10, 1.2, 1 decimal 2. Remember, we write 1 by 10 as 0.1, 12 by 10, 1.2, 13 by 10 as 1.3, etc. Hundredths, 1 by 100 or 0.01. Let us divide a square into 100 parts and shade one part. The shaded part represents 1/100th or 1 by 100. We denote it by 0.01 and read it as decimal 01. A decimal fraction with 100 as denominator has 2 digits after the decimal point because the denominator has 2 zeros at its end. 0.01, 1 by 100, is different, smaller from 0.1, 1 by 10. We can continue the hundredths in the following chart. Fractional number 1/100th, common fraction 1 by 100, decimal fraction 0.01, read as decimal 01. And let us continue reading for 200th, 2 by 100, 0.02, decimal 02. 300th, common fraction 3 by 100, decimal fraction 0.03, read as decimal 03. 900th, 9 by 100, 0.09, decimal 09. 1000th, 10 by 100, 0.10, decimal 10. 1100ths, 11 by 100, 0.11, decimal 11. 50 hundredth, 50 by 100, 0.50, decimal 50. 99 hundredth, 99 by 100, 0.99, decimal 99. Digits after the decimal point are read separately. While writing hundredths, we may add 0 if required to make 2 digits after the decimal point. Example 1. Write the following in decimal form. 24 by 10, which is equal to 2.4. Place decimal before one digit from the right. 24 by 100, which is equal to 0.24. Place decimal before two digits from the right. 124 by 10 is equal to 12.4. Place decimal before one digit from the right. 124 by 100 is equal to 1.24. Place decimal before two digits from the right. 1 by 10 is equal to 5.1, where 1 by 10 is represented as 0.1. 2 by 100, which is equal to 6.02. So add 1 0 to make two digits after the decimal. 25 1 by 100 is equal to 25.01. Add 1 0 to make two digits after the decimal. 10 17 by 100 is equal to 10.17. Relation between tens and hundreds. 1 by 10 is equal to 1 into 10 divided by 10 into 10, which is equal to 10 by 100, or 10 by 100 is equal to 1 by 10. 0.10 is equal to 0.1, which are called as equivalent decimals. So 10 by 100 is equal to 1 by 10.
Thousandths. 1 by 1000 or 0.001. Suppose a three-dimensional figure 10 into 10 into 10 is divided into 1000 equal parts and one part is taken. That one part represents 1,000th part or 1 by 1000 of the whole. We denote it by 0.001 and read it as decimal 001 or 0.001. A decimal fraction with 1000 as denominator has 3 digits after the decimal point. We can continue the thousandths in the following chart: fractional number, common fraction, decimal fraction, read as 1000, 1 by 1000, 0.001, decimal 001. 2000ths, 2 by 1000, 0.002, decimal 002. 3000ths, 3 by 1000, 0.003, decimal 003. 9000ths, 9 by 1000, 0.009, decimal 009. 10,000ths, 0.010, decimal 010. 11,000ths, 11 by 1000, 0.011, decimal 011. 99,000ths, 99 by 1000, 0.099, decimal 099. 100,000ths, 100 by 1000, 0.100, decimal 100. 101,000ths, 101 by 1000, 0.101, decimal 101. 111,000ths, 111 by 1000, 0.111, decimal 111. 999,000ths, 999 by 1000, 0.999, decimal 999. Digits after the decimal point are read separately. While writing thousandths, we add extra zeros, if required, to make 3 digits after the decimal point. Decimal fractions in the place value chart. To understand the tens, hundredths and thousandths clearly, we extend the place value chart to the right of ones. we can write 0.1, 0.01 and 0.001 in the place value chart as follows. 1/10, 1 by 10th in tenths, 0.1, we don't have it in hundredths and thousandths. 100ths, 1 by 100 tenths, 0.0, hundredths, 1. 1000ths, 1 by 1000 tenths, 0.0, hundredths, 0, thousandths, 1. Example 2. Write the following decimal fractions in the place value chart. A. 25.6, B. 187.23, C. 1379.527.
Solution. Problem number A, 25.6. Write down 2 in tens, 5 in ones, put a point, and in tens, 1 by 10, put 6. B, 187.23. 1 in hundreds, 8 in tens, so 7 in ones, and put a point, 2 in tens, 3 in hundredths. 1379.527. Put 9 in ones, 7 in tens, 3 in hundreds, 1 in thousands. Put a point and write down 5 in tenths, 2 in hundredths, 7 in thousandths.
Expanded form. Expanded forms of the above decimal fractions are the following. 25.6 equals to 20 plus 5.6 or 20 plus 5 plus 6 by 10. 187.23 equals to 100 plus 80 plus 7 plus 0.2 plus 0.03 or 100 plus 80 plus 7 plus 2 by 10 plus 3 by 100. 1379.527 equals to 1000 plus 300 plus 70 plus 9 plus 0.5 plus 0.02 plus 0.007 or 1000 plus 300 plus 70 plus 9 plus 5 by 10 plus 2 by 100 plus 7 by 1000.
Place value of each digit. Example 3. Write the place value of each digit in 368.724. 368.724. 3 hundredths or 300. 6 tenths or 60, 8 ones or 8, 7 tenths or 7 by 10 or 0.7, 2 hundredths or 2 by 100 or 0.02, 4 thousandths or 4 by 1000 or 0.004. Example 4. Write the short standard form of a bit 400 plus 30 plus 5 plus 0.3 plus 0.01 plus 0.007. Solution 435.317. B bit 500 plus 70 plus 4 plus 2 by 10 plus 8 by 100 plus 9 by 1000 is equal to 574.289.
Equivalent decimal fractions. 4 by 10 equals to 4 into 10 by 10 into 10 equals to 40 by 100 or 0.4 equals to 0.40. 4 by 10 equals to 4 into 100 by 10 into 100 equals to 400 by 1000. 0.4 equals to 0.400. Thus, 0.4 equals to 0.40 equals to 0.400, equivalent decimal fraction. But 0.40 and 0.040 are not equivalent because 0.40 equals to 40 by 100 and 0.040 equals to 40 by 1000. Like and unlike decimals. Can you find odd one out among these decimals? 7.25, 13.65, 4.8, 72.16, 119.54. Yes, 4.8 is the odd one out as it has only one decimal place, whereas the others have two decimal places. Like decimals, the decimals having the same number of decimals place are known as like decimals. For example, 7.2, 4.8, 12.3, 178.4. Unlike decimals, the decimals that do not have the same number of decimal places are known as unlike decimals. For example, 6.9, 23.89, 4.71, 13.2. Example 5. Convert the unlike decimals into like decimals. A-bit 7.3 and 4.15. Solution. Number of decimal places in 7.3 equals to 1. Number of decimal places in 4.15 equals to 2. Here 7.3 has lesser number of decimal place. So we put a 0 the extreme right of 7.3 and write it as 7.30. Unlike decimal, 7.3, 4.15. Like decimal, 7.30 and 4.15. D-bit 51.2, 9.38 and 16.9. Number of decimal places in 51.2 equals to 1. Number of decimal places in 9.38 equals to 2. Number of decimal places in 16.9 equals to 1. Here, 51.2 and 16.9 have lesser number of decimal places. So, we put a 0 to the extreme right of 51.2 and 16.9 and write it as 51.20 and 16.90. Unlike decimal, 51.2, 9.38, 16.9. Like decimal, 51.20, 9.38, 16.90. Comparing decimals. To compare decimals, convert all the unlike decimals into the like decimals and then compare as normal numbers. Example 6. Compare the decimals 6.8 and 6.34. Solution 6.8 and 6.34. Step 1. Convert the unlike decimals into like decimals. Unlike decimal 6.8, 6.34. Like decimal 6.80, 6.34. Step 2. Place the decimals in the place value chart. Decimal 6.80, ones, 6, tenths, 8, hundredths, 0. Decimal 6.34, ones, 6, tenths, 3, hundredths, 4. Step 3. Now start to compare the digits from left as normal number. Decimal 6.80, ones, 6, tenths, 8, hundredths, 0. Decimal 6.80, ones, 6, tenths, 3, hundredths, 4. So 6.80 is greater than 6.34. Example 7. Arrange the decimals in ascending order. 7.8, 16.52, 7.54, 16.90. Solution. Step 1. Convert the unlike decimals into the like decimals. 7.54, 7.80, 16.52, 16.90. Step 2. Now compare and arrange the number from smallest to greatest. 7.54 is less than 7.80, less than 16.52, less than 16.90. Example 8. Arrange the decimals in descending order. 24.5, 68.3, 65.41, 24.97. Solution. Step 1. Convert the unlike decimals into like decimals. 24.50, 68.30, 65.41, 24.97. Step 2. Now, compare and arrange the number from the greatest to smallest. 68.30 is more than 65.41, which is more than 24.97. 24.97 is more than 24.50. Addition and subtraction of decimals. You can add and subtract decimal numbers as you do for whole numbers. Example 9. Add 8.4 and 0.78. Step 1. Write the decimal numbers in column. Put decimal points one below the other so that the digits in the same decimal are one below the other. Step 2. Change the decimals to like decimals if required. Step 3. Add the digits as you add whole numbers. Step 4. Write the decimal point in the answer in the same place as the number above it. Answer 9.18. Example 10. Subtract 3.68 from 8.42. Step 1. Write in columns, put decimal points one below the other so that the digits in the same place are one below the other. Step 2. Change the decimals to like decimals if necessary. Step 3. Subtract as you would subtract the whole numbers. Step 4. Put the decimal point in the answer at the same place. Answer 4.74. Story sums. Example 11. A rose plant that was 1.1 meter long in January rose by 6.25 meter in the month of February. What is the height of the plant in February? Solution. To find the height of the plant in February, you need to add 1.1 meter and 6.25 meter. Height of the plant in January equals to 1.1 meter. Growth of the plant in February equals to 6.25 meter. Height of the plant in February equals to 1.1 plus 6.25 meter equals to 7.35 meter. Answer. The plant is 7.35 meter high in February. Example 12. Neetu bought 4.8 meter of ribbon to pack a present. How much ribbon is left if she used 3.6 meter? To find the ribbon left with Neetu, you need to subtract 3.6 meter from 4.8 meter. Answer. Neetu has 1.2 meter of ribbon left. No more. Do not forget to write the decimal point in the answer. Multiplication of money by a whole number. To multiply money, you just follow the same steps as you would when multiplying whole numbers. Just remember to place the decimal point 2 digits from the right in the final result. Example 13. A chocolate ice cream costs Rs 15.25. What is the cost of 8 ice creams? Solution. Cost of 1 ice cream equals to Rs 15.25. Therefore, cost of 8 ice creams equals to Rs 15.25 into 8, which is equal to Rs 122.00. Put a decimal point after 2 digits from the right. The cost of 8 ice creams is Rs 122. Example 14. The exchange rate between US dollars and Indian rupees changes frequently. If 1 US dollar is equal to 82.60 rupees, how much would an item that cost 15 US dollars cost in Indian rupees? Solution: 1 US dollar equals to rupees 82.60. $15 equals to 15 into rupees 82.60 equals to rupees 1239.00. The cost of the item in Indian rupees is rupees 1239. Division of money by a whole number. To divide money, the process is the same as dividing whole numbers. You can align the decimal point in the quotient with the decimal point in the dividend. Example 15. The cost of a packet of 12 pens is rupees 48.60. What is the cost of 1 pen? Solution: cost of 12 pens equals to rupees 48.60. Therefore, cost of 1 pen equals to rupees 48.60 divided by 12 equals to rupees 4.05. Example 16. 9 glasses of juice cost rupees 232.65. What is the cost of 1 glass? Solution: cost of 9 glasses of juice equals to rupees 232.65. Therefore, cost of 1 glass equals to rupees 232.65 divided by 9, which is equal to rupees 25.85. Estimating total cost. To make a rough estimate of the sum of a set of numbers, you can round each number to its highest place value and then add the rounded numbers. Example 17. 2 friends went to a store to buy the following comic books. Harry Potter, quantity 2, price of 1 book, rupees 220.50. Home Alone, quantity 3, price of 1 book, 212.75. Superman, quantity 1, price of 1 book, rupees 295.50. Estimate the total amount needed to purchase the above comic books. Solution: here we round off each of the given prices to the nearest hundreds. Comic books. Harry Potter, quantity 2, actual price 220.50. Estimated price of 1 book 200. Estimated price as per the given quantity 200 into 2 equals to rupees 400. Home Alone, quantity 2, actual price 212.75. Estimated price of 1 book 200. Estimated price as per the given quantity 200 into 2 equals to 400. Superman 3, 295.50. Estimated price of 1 book rupees 300. Estimated price as per the given quantity 300 into 3 equals to 900. Total 1700 rupees. The estimated total cost is rupees 1700. Values and life skills. Manish took his grandparents to Haridwar. He covered 154.5 kilometers by train and 42.7 kilometers by car. How much distance did he travel?